So now, in the last slide, we have 4 different products, and there is a way you can control the selectivity of the reaction. Right. So you can choose an aldehyde like this. What aldehyde is this? What's it? Formaldehyde, right. Formaldehyde. Okay, does it have an alpha carbon? It doesn't have an alpha carbon, so you cannot deprotonate this molecule, right? You cannot deprotonate this molecule, so it can only act as an electrophile. It cannot act as an enolate, the nucleophile, right? Okay, let's choose another molecule that is acetophenone. Now, can you draw the product of this? Formaldehyde does not have an alpha carbon, so that can only act as an electrophile. Right. Acetophenone, that's what we used in last week's lab, has an alpha carbon. You can deprotonate that and get an enolate that is a nucleophile. Did anybody get the product? Okay, so that's, okay, so you're making an alpha carbon, you're converting this into enolate, and make a bond between this nucleophile and this electrophile. So you're missing a carbon. Okay. What do you get, Taylor? Okay. Can take a picture of this. Okay. So this is from Tyler. Okay, you have a formaldehyde and acetophenone, formaldehyde and acetophenone. There's only one alpha carbon that has a hydrogen, right? This alpha carbon does not have a hydrogen. You're not going to deprotonate that. You're going to deprotonate this alpha carbon and get a negative charge on that. And that's going to attack this electrophilic carbon. So you make a new sigma bond that's here. Right. The new sigma bond is there between the alpha. Sorry, that's my bad. New sigma bond is here between the alpha carbon and the carbon of formaldehyde, the carbonyl carbon of the formaldehyde. And since formaldehyde is the lowest aldehyde, right? You have hydrogens on both sides, so that's the lowest molecular weight aldehyde, and you will end up with a primary alcohol, right? A primary alcohol, because you have 2 hydrogens and 1 carbon, 2 hydrogens and 1 carbon. So that's a primary alcohol. Okay, so that's good.